welcome to another video. This time we're going to create a fluid orb like you would see here. And we can of course change this to preview our health. So for example, like you have in many games like Diablo or any top-down RPG, they often have like these fluid orbs. So let's build this together with Houdini and Unreal and talk a bit about how this was created. So we're going to get started with the Houdini part first. There are many ways of doing this. Like we can do an actual fluid simulation. We can calculate like a fancy heavy fluid simulation, but we can also do it in a very simple way, which I'm going to show you first. So we're going to start out by making a box, for example, just a simple box like here. Maybe let's change this to 2 by 2. Doesn't matter that much, but just something to start with. Then the idea is that I will basically boolean out in noising. So I will make the surface a bit more noisy. So we'll make a grid that is of course bigger like this. Maybe we can target it a bit up, doesn't matter too much. And we're gonna make the grid a bit smaller because we want to increase the poly count. So we want to boolean a noise, which we will need more geometry for. So we don't need to worry too much about geometry since we will render this out into textures. So let's say this can be 4 by 4. So I think it should capture the box. And then let's say this is 100 by 100 rows and columns. So we have enough data to modify. So if we now would do a noising pass with a mountain noise, we can see that we can now add like these roughnesses here. What I will usually do, I mean, fluid is not usually that fine in roughness. So what I will do here is I will go to a fractal and disable here the fractal type. So you can see that we'll make it less noisy. So we'll just something like a smooth plane like this. We can maybe tweak the size here a little bit. Maybe we can fine tune the intensity, something like this. You can of course go back and forward. Now the trick here is basically a boolean. So we will boolean one into another like so. And then we have something like this. So this is now basically upside down. And to solve this, we can reverse the polygon. So here reversing the polygons, this will now result in something like this. So there we have it, like a basic fluid shape sort of. And the movement will basically happen from either the noising being offset. So if we offset the noise, we have some movement. Or what we can also simply do is we can spin this around, which will give it more like an orb effect. So if we use a transform here, and we need to basically say that this needs to rotate and basically loop. So if we just make this loopable, we just need to have 360 degrees. Which also comes to the next point, is the number of frames that we're going to use. So we will bake this out to render this out in a spreadsheet, which will basically sort of like be a flipbook. So we have a collection of images. To put some thought into our images, we're gonna say let's use a 6 by 6 spreadsheet, which means that we will have 36 frames. So 36 frames in total. So that means that our rotation like this needs to be our number of frames multiplied by the number that will accomplish to 360 degrees. So in this case by 10. So this will make it sort of like loopable. So 36 by 10 will make it loopable. So if you do it like this, we'll spin super fast. So let's go into our properties like this. Let's set real-time playback and maybe let's lower the FPS to 12. So normally now it should spin way slower. So we will now, if you look on the side, so we will capture it from the side like so. You will see it will be loopable. Maybe place a null node. So we can see it like this. So we'll have something like this that will be captured. And this is sort of like our fake fluid moving. So this is, like I said, one way of doing this. Now another way would be simulation. Now on the simulation side of things, I'm not going to explain too much because I've also used for the final outcome, I used the older method, the one where I just do the boolean. So, but you can definitely do a simulation. So first of all, if you want to use the new sub flip nodes, we're going to create a tank. This is sort of like the area where fluid can be calculated rather. Then we create an object where we want to represent it by the fluid. So this sphere is currently my sort of like orb, my fluid orb. And then we can configure this by using the flip boundary node. And there's some settings here, but most of it is just default. And then we also want to have a collider. So the collider, for example, could be a reversed sphere. So I took a box and I hollowed out this sphere. So the fluid sort of like will sit in this sphere. So again, there is other ways you can do this, but this will work. So we will spawn fluid in the middle of this collision, and it will just stick there and it will rotate. So here, if I would press the simulation, maybe I can output the final output here. So if I press simulation, it will fall down, we'll create some fluid, and you can see it going. So this is like a more actual fluid simulation, as you can see. So you can increase the quality, add more particles to fine tune. Like here, the particle separation is on the higher side, so you can lower this to get a bit more quality in fluid. And you can also increase the resolution and so on. But this would be like a fluid way. So again, you define your fluid emitter, you define a collision, you can run it to a solver, and then you can do some compression and surfacing to make something like this. So this is one way as well to do an actual fluid simulation. So for both of these, the way that we want to render them out will be the same. One more thing here is we can also do make loopable, because we want to, of course, make this loopable. So you can plug this in and we'll try to make it loop. So that's also good to know here as well. So this will be the one that I will use as my final one. I will now want to set a camera and render this out. So to set a camera, I'm just going to take an angle like this, something that I'm happy with. And I'm going to set here, new camera, and this will be my rendering area. So of course we want this to be in a square. So we're going to go to view. We're going to set this, for example, to the lowest resolution. It doesn't matter too much. And we're also going to say that this will be an orthographic view. So it will also change that as well. So we can modify here either the camera here, try to move it better. We can also just grab the slider here and zoom in like so. So we have something like this. You can, again, modify it depending on how much you want to see these waves going on. You can tilt the camera, rotate the camera. So in this case, for example, you will have something like this. So it's a nice loopable sort of like fluid feel of a simulation here. So let's say I'm happy with this. You can, of course, come back and go forward and tweak things and play around with values. We want to create a rendering network, so ROP network. You can also switch it here. And here we're going to use the Flipbook tools, so lab Flipbook. So our range is by default targeted or get from our timeline. So I already specified this to be 36. So we will have a 6x6 spreadsheet. Our camera here is going to be camera 1 that we just created. Then this node itself is usually used for volumes, but we don't have any volumes, so don't fill this in. Then we want to have a custom non-volumetric geometry, which will be our simulation, or rather our boolean. And I think I used the null node as output. So just to be checking, we can always, for example, call this like out, and we want to target this node, of course. So that node needs to be rendered out. So here, geometry1/out node. So that is done. Of course, the main trick here is then setting our resolution. So if we have a 6x6 spreadsheet, that means that we have a total resolution of this. So we don't have to lower this. So this is the most tricky part here, is to find this resolution. So let's say this is, for example, 370, which will be coming close to like a 4K, a 2K texture. So it's going to be quite difficult to get like a perfect match to that resolution. But afterwards in Photoshop or Substance Designer, I will actually set out the correct resolution. So we're just going to bake this out in a bit higher resolution. But afterwards, we're going to just set it to proper game res, of course. Now, we're also going to go to color space. So if you don't have the ACES installed for Houdini, you can click this button or you can switch to linear. It doesn't matter. Results will be somewhat similar, but it's up to you, especially since we're not working with volumetrics, but just geometry. I just kept it to linear. And once you're done with that, we're going to simply click render and wait out when it's done. Once it's finished, you might have a texture that looks like this. So we can see the waviness or the frames of each rotation we made with the noise. So that's all coming out nice together. And then I will modify the renders or the outputs in Substance Designer in this case. So we had two outputs. One was the output here where we had some information about the opacity and depth map, as you can see. This might be called the ECD output and also the FC output. So those are the two maps that I'm going to use here. So if we look into Houdini, we have our exports, and here you can see that we have these two outputs that we want to use. So we have the FC and the ECD. So FC stands for final color. So these are just the actual viewport colors. So this will probably just be gray. And then we also have the ECD, which stands for emissive, and the depth map, which I'm actually mainly interested in the depth here. So we're going to combine these things in a custom texture. I could as well also like create this here, like I can easily modify it over here. But I decided to do it in Substance so I can like maybe tweak a couple things a bit more. So we have those maps. So this is the depth map and this is then the color map. So from the depth, I'm just going to take the alpha channel, which was the depth. And in here, I'm going to apply like a little blur on it. So it's up to you if you want to blur it as well. Then for the final color, I did an auto level. So this sort of like could be used as my sort of like AO. So I could use this to fake some like AO in it. So the part that will be close to sort of like this glass orb feel will be lighter, and then the back or the top surface will be a bit darker, as you can see. Then we also have then just an opacity map as well. So again, just useful for cutting off where the fluid should happen. And then we just combine it into this new texture where again, I have the depth, the color, and just a general mask. And then we have something like this. We can also here, if you want to continue, I also made the shape like this for the final output, but maybe I'll come back to it once I go to that part. So in Unreal, I have imported my texture, as you can see, the fluid orb texture, and we're going to make a new material. So I'm going to start from scratch here. So orb one or orb tutorial. So then we have here the material. As we know, we are working with a flipbook. So the most basic thing to get this working is using the node called Flipbook. So Houdini so Unreal provides a node for this by default. We need to give it texture. So let's do a texture object. So, and in this texture object, we of course need to fill in our flipbook texture. And this can be linked. So the rows and columns are the same. So they are 6 by 6. So again, 36 frames. And this should actually already work. So if I plug this in the base color, and if I would now here enable also just a plain view, we have something like this. So this already works pretty well. So we have like this fluid sort of like turning around in an orb. Now we're going to have to also set the animation phase. So this can be simply done by using time, multiplying by the amount of speed, for example. So let's say 0.25. And this will now run a bit slower, as you can see. So we'll be a bit more relaxed. And that's the basic setup for this to work. You can get this working already by just using this node. So there's no special setup there. Now, one more other thing, of course, is we want to have this to be in an orb, in a sphere, the opacity. So for example, let's just mask it out. So either you can create masks in Substance Designer. I did that as well, as you can see. I created some masks for this to work with. But you can also just use other things like the radial gradient exponential. So if you would plug this in like so, you also here have like this orb. So that's basically how we can do it as well. So if I would, for example, bring in my texture like so, it has a couple data stored. So I can use the red channel was my opacity, and I can also then use my normal map to bump it a bit more to make it feel like it's a more orb shape, like so. It looks a bit nicer, so I can press save. So like I mentioned in Substance Designer, I made this basic graph. So I basically took two spheres and made a ring out with this. Then I did a small bevel of that ring, and then I combined it together with like another shape here. So we have a shape like this, and then I get the normal map from that. So again, the same thing that I did is I used this or stored this as an additional texture as a masking, so I can mask out the ring and the other elements. So for example, I know that my green channel is the ring, so I can do something like this. Now, to further improve on this, so maybe let's first set up some basic colors, so it's not only the blue and red. So let's break it down by using the mask component node, so here. So we can start out with the red channel, and we can simply lerp this between two colors, for example. So let's say, maybe to make it a bit noticeable, let's start with red and maybe blue. So let's grab a bluish color. So we can clearly again see the difference between it, or maybe green. So it's like different from what I actually see here. So it's also red and blue. So maybe make it green. So we can also preview this node over here, and that's a nice view. So this is actually our depth map. As you can see, like there's some depth going on. So we can multiply this by a certain value. Let's say 20. You will see what will happen. So we can boost that up more. We probably want to maybe do a clamping of this, like so. So we can sort of like force the top color or the blending color to be a bit greenish. But I will change that in a moment. Let's maybe also now use our mask to cut off the fluid to then merge again in our system. So here, if I grab my other channel, I think it was in the blue channel that my mask was, I can simply do a lerp again, and this can be the mask. So let's use it like this. And I think if I now preview this, we should now have a mask, like so. So you can see that the top color is changeable by using the depth sort of. So we can just simply make this maybe a bit more orange, like so. And then we can drag this in over here and stop previewing, and you will see we have now something like this. So we're almost there, like it's looking pretty good there. Of course, like a very funny small elements you can fine tune, but the base setup is looking pretty good. What also we can do is the main thing that we want to use this for is, for example, displaying your health of the player, for example. So we want to have a slider that goes from 0 to 1, defining how high this should go. Now, the thing that we need to do is we need to modify the UV coordinates. So we need to multiply or offset the UV coordinates by certain values. So what we want to do is, if we would now, for example, grab the UV coordinates and let's do an add to the UV coordinates. Let's say here, let's say we add 0.4. You will see that this will, of course, start to break and fall apart. You can see now suddenly we see the bottom of the texture. If we will look at the texture, we of course start to see the bottom. So we want to actually zoom in on our UV a bit, and then we can move with more space. So multiply this by 0.5, which means we will zoom on the texture. So if we do that, you can see that we're now actually having like a filled orb. Now let's make our custom values. So we're going to have to use the Y as our health amount. And we will do that by using the append. So we can combine multiple values. So we have the R and the G value. So our first value will probably be 0, since this will be the X value. So this goes in that direction. The Y is the height. Then what I've did to control this a bit more is using a lerp again. So the lerp will basically be the range of the maximum and minimum in the UV space. So let's say it can go from 0 to probably something like 0.5. So here, this is my health. Maybe we can promote this to parameter, of course. So when our health is 1, it should be fully filled. So let's check if that will work. So that works. You can see there is still like some little movement animation sometimes, so you can tweak that value a bit. And when our health would be at 0.5, which means we should be roughly at the middle, so that also works. And when our health is fully at 0, we should basically almost see nothing, as you can see. So this sort of like remapping the value a little bit. There is also like a remapping node as well. That will also work. But here we just simply go from 0 to 0.5 in the UV space. So we need to map to that value. And this is then our health slider. So I can now increase this to have more or less health on the player. So of course we can clamp the slider to 0 and 1. We should not go anything out those values. And that's sort of like the basic shader in Unreal. So for example, here I did some additional tweaks to this. I, for example, added some sparks, as you can see. So when the health drops, I will actually remove the sparks a little bit. And if we have full health, I will actually show more of these sort of like sparks coming up. We can also do lightness, saturation, some additional coloring, So it's all up to you what you want to add. So this is sort of like a bit more improvement on this. So it's further up to you if you want to improve this, but this should give you a good idea of how to build something like this, where we have like a fluid orb displaying your health bar in the game, for example. Hope you enjoyed this video. Thanks for watching. Like and subscribe.